Hello everyone. So, as we have completed the topic of refraction of a light through a glass prism, I hope you are clear with this. We have seen how a white color light incidents into a glass prism and it refracts to form the another direction or a medium and thus forming the rainbow color. Fine. The rainbow color was consisting of Vibgyor, that was the violet, indigo, blue, green, yellow, orange and red. Fine. Here the angle A was said to be the angle of prism, angle E was the emergent ray, I was the angle of incidence, R was the angle of refraction, as well as the D was the angle of deviation. D was the angle of deviation. Fine students, I hope you are clear with this. You need to draw this figure in the examinations if they are asking the question that write a short note on refraction of a light through a triangular glass prism. I repeat, refraction of light through a triangular glass prism. Fine. We have also seen the formation of the rainbow that was done by the dispersion of white light by a glass prism. That was the dispersion of a white light by a glass prism. Okay, the dispersion of a white light and the spectrum formed was the various colors were seen whenever the white light was incident into a glass prism, and that was violet, indigo, blue, green, yellow, orange and red. Okay. The short form of the violet, indigo, blue, green, yellow, orange, red is known as Vibgyor. It is known as Vibgyor. Okay. So as we have also seen that the band of the colored components of a light beam is called its spectrum. The band of the colored components of a light beam is called its spectrum. And the splitting of the white light into 7 component colors is known as dispersion. Repeat, the splitting of the white light into 7 component colors is called its dispersion. Fine. As we have seen that the different colors of light bends through different angles with respect to the incident ray as they passes through a prism. The red light bends the least, while the violet light bends the most. Please note that students, the red light bends the least, while the violet light bends the most. Thus, the rays of each color emerge along different paths and thus becomes different. It is the band of different colors that we see in a spectrum. As we have also seen how Isaac Newton experimented on the glass prism. He kept more than 2 or 3 prisms side by side equally, and he was thinking about to getting more colors being refracted, but at last he got to know that only 7 colors are formed, that was the violet, indigo, blue, green, yellow, orange, red, in from a white light, from a white light. Fine students, see. But he also did one more experiment, and that was known as the recombination of the spectrum of white light. That was the recombination of spectrum of a white light. Isaac Newton was the first to use a glass prism to obtain the spectrum of a sunlight. He tried to split the colors of the spectrum of white light by further using another similar prism. Okay, he then placed a second identical prism in an inverted position with respect to the prism. Fine. This allowed all the colors of the spectrum to pass through the second prism. He found a beam of light emerging from the other side of the second prism. This observation also gave Newton the idea that the sunlight is also made up of 7 colors. Without refraction, the sunlight is also often referred as a white light. Sunlight is also often referred as a white light. Fine students? A rainbow is a natural spectrum appearing in the sky after rain shower. A rainbow is a natural spectrum appearing in the sky after rain shower. It is caused by the dispersion of sunlight by tiny water droplets present in the atmosphere. A rainbow is always formed in the direction opposite to that of sun. A rainbow is always formed in the direction opposite to that of sun. Please note that students, that is quite important for you. You can also see a rainbow on a sunny day when you look at the sky after a rainfall, waterfall, water fountain, etc. Okay, and the next topic that we started yesterday and we are going to go in detail is the atmospheric refraction. As we have seen, the flickering, wavering, or the shivering objects about the turbulent hot stream. Why does this happen? Because the air just above the fire becomes hotter than the air further up. The hotter air is lighter, less dense than the cooler air above it, and has a refractive index slightly less than that of cooler air. Since the physical conditions of the refracting medium are not stationary, the apparent position of the object as seen through the hot air fluctuates. This wavering is thus an effect of atmospheric refraction on a small scale in our local environment. Then, what are the causes of atmospheric refraction that we need to see? So, the first thing is, what are the causes of atmospheric refraction? Fine, students. The twinkling of stars is due to the atmospheric refraction. Please note that the twinkling of stars is due to the atmospheric refraction of a starlight. The starlight on entering the Earth's atmosphere undergoes refraction continuously before it reaches the Earth. The atmospheric refraction occurs in a medium of gradually changing refractive index. The atmospheric refraction occurs in a medium of gradually changing refractive index. Since the atmosphere bends starlight towards the normal, the apparent position of the star is slightly different from its actual position. Students, please note that there is a difference between the actual position and apparent position. Because the sunlight bends a little due to the highly thick atmosphere present between the eyes and the sun. Fine, we will see the stars of the different position. See over here, students, in the figure number 11.9, they have given us the apparent star position due to atmospheric refraction. So, the real path is the straight line given, and while the dotted line indicates the apparent position. Here, the dotted line stands for the apparent star position, that is the unrealistic or the fake star position, but due to the atmospheric refraction, it will look like this. Fine, students, I hope you are clear with this. The star appears slightly above than its actual position when viewed near the horizon. This apparent position of the star is not stationary but keeps on changing slightly. Since the physical conditions of the Earth's atmosphere are not stationary, as was the case in previous graph, since the stars are very distant, they approximate point-sized sources of light. As the path of the rays of the light coming from the star goes on varying slightly, the apparent position of the star fluctuates, and the amount of star entering the eye flickers. The star sometimes appears brighter and at the same other time sometimes look fainter, which is also known as twinkling of stars. Please students, this is the one of the most important give reasons of this chapter. Why do stars twinkle at night? Why do stars twinkles at night? Then please note that since the stars are very distant, they approximate the point-sized sources of light. As the path of the rays of light coming from the stars goes on varying slightly, the apparent position of the star fluctuates and the amount of starlight entering the eye flickers. Star sometimes appear brighter and at the same time looks fainter, which is also known as twinkling effects. So if the stars twinkle at night, there is another question. Why don't the planets twinkle? Why don't the planets twinkle? The planets are much closer to the Earth and are thus seen to be an extended sources. I repeat, the planets are much closer to the Earth and are seen as an extended sources. If we consider a planet as a collection of large number of point-sized sources of light, the total variation in the amount of light entering our eye from the individual point-sized sources will average out to zero, thereby nullifying the twinkling effect. Fine. So stars twinkles at night, but the planets do not twinkle at night, as they will nullify the twinkling effects. Have you ever observed that whenever the sun is not seen, still there is a brightness over here? Or we can see the sunlight before the sun rises and even after the sun sets. Why does this happen? The main cause of this is the advanced sunrise and the delayed sunset. It is advanced sunrise and the delayed sunset. The sun is visible to us The sun is visible to us about 2 minutes before the actual sunrise and about 2 minutes after the actual sunset because of the atmospheric refraction. Fine students, the sun is visible to us after about 2 minutes before the sunrise and about 2 minutes after the actual sunset because of the atmospheric refraction. By actual sunrise we mean actual crossing of the horizon. Shows that the actual and the apparent position of the sun with respect to the horizon. There is a time difference between the actual sunset and the apparent sunset is about 2 minutes. The apparent flattening of the sun's disk at sunrise and sunset is also due to the same phenomena. Fine students, I hope you are clear. See, there is a horizon at the surface of the earth. Then what is the definition of the horizon? We can name it the imaginary horizontal line passing through the surface of the earth is known as horizon. It is known as horizon. The imaginary horizontal line passing through the surface of the earth is known as horizon. Fine students, the apparent flattening of the sun's disk at the sunrise and sunset is also due to the same phenomena. Fine students, I hope you are clear with this. Fine. So if you are clear with the twinkling of the effects of the stars, why do planets do not twinkle? And at last, the advanced sunrise and the delayed sunset. Let us move on to the next topic, the scattering of light. The interplay of light with objects around us give rise to the several spectacular phenomena in nature. The interplay of light with objects around us give the rise to the several spectacular phenomena in nature. The blue color of the sky, color of the water in the deep sea, the reddening of the sun at the sunrise and the sunset are some of the wonderful phenomena we are familiar with. Okay, yes, at the sunrise or the sunset, the sky looks red in color, but instead of that, in the noon or in the afternoon, the sky looks blue in color. We are familiar with it. Why does this happen? As you all know, the atmosphere is filled up of various types of colloidal particles. Here the colloidal particle stands for smoke, dust, fog, smoke, and each and every types of gases filled with mixture. Fine students. So what happens? Due to this, the atmosphere gets thick. And sometimes a true solution is also not visible. Let us read that. In the previous class, you have learnt about the scattering of light by a colloidal particles. The path of a beam of a light passing through a true solution is not visible. However, its paths become visible through a colloidal solution where the size of the particle is relatively larger, where the size of the particle is relatively larger. What happens during this time? Let us see that. The first phenomena about atmosphere scattering of light is the Tyndall's effect. This is the Tyndall's effect. What is Tyndall's effect? Let me explain you. Have you ever seen whenever you wake up in the morning and open the curtains, there is a beam of light traveling into your room? They are also containing small, very tiny mixtures which are floating in air. Fine. These are the colloidal particles. These colloidal particles, as I told you, consist of smoke, dust, ash particles, various types of gases, etc. As the light above the room is more brighter, we can clearly see the path. The best examples of the Tyndall's effect is the canopy of the dense forest, where the sun rays are coming from the small holes of the trees, as well as the smoke-filled room and the hole in it. Fine. Let us read the Tyndall's effect. Let us go through the Tyndall's effect. The Earth's atmosphere is a heterogeneous mixture of minute particles. Repeat. The Earth's atmosphere is a heterogeneous mixture of minute particles. These particles include smoke, tiny water droplets, suspended particles of dust, and the molecules of air. Fine, students. The Earth's atmosphere is a heterogeneous mixture of minute particles. These particles include smoke, tiny water droplets, suspended particles of dust, and molecules of air. When a beam of white light strikes such fine particles, the path of beam becomes visible. The path of beam becomes visible. This light reaches after being reflected diffusely by these particles. The phenomena of scattering of light by a colloidal particle gives rise to the Tyndall's effect. The phenomena of scattering of light by a colloidal particles give rise to the Tyndall's effect. This phenomena is seen when a fine beam of sunlight enters a smoke-filled room through a small hole. I repeat, phenomena is seen when a fine beam of sunlight enters a smoke-filled room through a small hole. Thus, scattering of white light makes the particles visible. Thus, the scattering of white light makes the particle visible. Tyndall effect can also be observed when sunlight passes through a canopy of a dense forest. Here, tiny water droplets in the moisture scatters light. Please note that, students, here the word mist stands for moisture. Here the word mist stands for moisture. Okay, I hope you are clear with this. So this is known as Tyndall's effect. The color of the scattered light also depends on the size of the scattering particles. I repeat, the color of the scattered light depends on the sizes of the particles. Very fine particles scatter mainly blue colored light, while the particles of the larger size scatter the light of the longer wavelength. Please note that, students, as the particles are smaller, very fine particles stands for very small particles. Then very fine particles scatter mainly blue light, while the particles of the larger size scatter light of the longer wavelength. Scatters light of the longer wavelength. If the size of the scattering particle is large enough, then the scattering light may even appear white. That the scattered light even appear white. Fine, students, I hope you are clear with this. If you are having any doubts, then you please let me know. Okay, so this was the Tyndall's effect that we studied just now. This was the Tyndall's effect that we studied just now. Let us move on to the next topic. And that is, why is the color of the clear sky blue? As I told you, students, the sky is filled with colloidal particles, and these colloidal particles are very small. We also studied that the very fine particles, that is the very small particles, are completely filled, are blue in color. That means they scatter blue color. Okay, so let us give the answer about why is the color of the sky blue in color. The molecules of air and other fine particles in the atmosphere have size smaller than the wavelength of the visible light. Repeat. The molecules of air and other fine particles in the atmosphere have smaller than the wavelength of the visible light. These are more effective in scattering of light of shorter wavelengths at the blue end than the light of the longer wavelengths at the red end. Please note that the wavelength of the blue colored light is shorter, whereas the wavelength of the red colored light is longer. The red light has a wavelength of about 1.8 times greater than the blue light. The red light has a wavelength about 1.8 times greater than the blue light. Thus, when a sunlight passes through the atmosphere, the particles in air scatter the blue light. The particles in the air scatter the blue light more strongly than the red. The scattered blue light enters our eyes. But if the earth had no atmosphere, there would not have been any scattering. Please remember, students, the scattered blue light enters our eyes, but if the earth had no atmosphere, there would not have been any scattering. The sky would have looked dark. Sky appears dark to the passengers flying at a very high altitude, as scattering is not prominent at such heights. Fine, students, I hope you are clear with this. You might have observed that the danger signal lights are red in color. The red is the least scattered light by a fog or smoke. Therefore, it can be seen in the same color at a certain distance. Fine, students, I hope you are clear with this. Once more I am repeating, the sky appears dark to the passengers because they are flying at very high altitude and the scattering is not possible at such heights. Okay, and so the astronomers which are flying they can look everywhere dark. And the red color light are used for the danger signals because it is least scattered by fog or a smoke. Therefore, it can be seen in the same color at a distance. Okay, I hope you are clear with this, students. Let us move on to the next topic, and that is the color of the sun at the sunrise and the sunset. The color of the sun at the sunrise and the sunset. Have you seen the sky and the sun at sunrise or the sunset? Yes, of course we have seen the sky at the sunrise and the sunset. Is it look any familiar to the daytime? No. See, students, the sunrise and the sunset are generally they are generally red, pink or orange in color. Whereas in the normal daytime, the sky looks blue in color. Have you ever wondered as to why the sun and the surrounding sky appears red during the sunrise and the sunset? Let us do an activity to understand the blue color of the sky and the reddish appearance of the sun at the sunrise or the sunset. See, students, they have given over here the activities as to how we can see that the sun looks red in color during the sunrise or the sunset. Let us see that. Place a strong source S of a white light at the focus of a converging lens. These lens provide a parallel beam of light. Allow the light beam to pass through a transparent glass tank containing clear water. Allow the beam of light to pass through a circular hole made in a cardboard. Obtain a sharp image of the circular hole on a screen using a second converging lens. obtain a sharp image of a circular hole on a screen using converging lens. Now, dissolve about 200 gram of sodium thiosulfate, also known as sodium hyposulfate. Remember students, the another name of the sodium hyposulfate is also known as sodium thiosulfate, in about 2 liter of clean water tank in it. Add about 1 to 2 milli of the concentrated sulfuric acid to water. Let us see what happens. You will find fine microparticles or microsulfur particles precipitating in about 2 to 3 minutes. As the sulfur particles begin to form, as the sulfur particles begin to form, you can observe the blue light from all the three sides of the glass tank. Yes, students, over here in the figure number 11.11, it is named as the arrangement for observing the scattering of light in a colloidal solution. You can see from all the directions white colored light is produced. Fine. This is due to the scattering of the short wavelengths by the minute colloidal sulfur particles. This is due to scattering of short wavelength by minute colloidal sulfur particles. Observe the color of the transmitted light from the fourth side of the glass tank facing the circular hole. Facing the circular hole. Fine. So you can see that all the rays are concentrated at one point. All the rays are concentrated at one point. Observe the color of the transmitted light from the fourth side of the glass tank facing the circular hole. It is interesting to observe that at first the orange red color and the bright crimson red color is found on the screen. So students, which colored light is found on the screen? It is interesting to observe that at the first orange red color and the crimson red color is found on the screen. Fine students, I hope you are clear with this. This actually demonstrates the scattering of light that helps you to understand the bluish color of the sky and the reddish appearance of the sun at the sunrise and the sunset. Fine students, I hope you are clear with this. If you are having any doubts, then you please let me know. We are keeping it till here today. I hope you are clear with this. Thank you. You need to write a short note on why the color of the clear sky is blue or the color of the sun at the sunrise and the sunset, as well as the twinkling of the stars and why do not the planets twinkle. Thank you.